And then moving on to step 2 of this work stress impacting personal life, we know that our step 2 is our planning stage. So step 2, and it's our planning stage in that we're going to use the central limit theorem, if we can, to find the distribution of the p-hats. Of all possible p-hats we could have collected, how do they behave? And so we start with our requirements of the central limit theorem for p-hat. Again, these requirements are found back in Module 11. The first one is simple random sample, and they said they randomly selected employees, and there wasn't any evidence that it wasn't a simple random sample, so we're going to go with it. The next thing, remember, n times p has to be bigger than or equal to 10, and n times q has to be bigger than or equal to 10. So if I want to take care of both of these in one shot, I'm going to look at the smaller of these two. And remember, P was 75% and Q was 25%. So if 25% is bigger than 10, 75% is going to be bigger than 10. So I'm going to just check that one, and I get 2 for the price of 1. So I get 100. Oh, I'm sorry, not 100 was not our sample space. Our N was 90. So let me make sure I get that correct. Our N was 90, and we've got 0.25 times 90. That's going to come out to 22.5, I believe. Make sure you're doing this with me and you get these calculations for yourself as well. Don't just trust me, because I make mistakes too. But I think that one's correct, and so we can move on. Since we are n times q, our number of failures is greater than 10, and our number of successes. The third thing we have to check is that our population size is bigger than 10 times 90. And so that would be, is our population size bigger than 900? And remember, they said this was this population is the number of all employees in this large of restaurants. So they did say it was a large chain of restaurants. So I'm going to think that this is going to be greater than or equal to 900 than if it's a very large chain. All right, so since the central limit theorem, we've met all the requirements, we now get our conclusion for the central limit theorem, which is awesome. So by the central limit theorem, we know that the p-hats are going to follow a normal distribution. They're going to center on the population proportion, which, based on our null hypothesis, we're assuming to be 0.75. So the p-hats should center on that 0.75, and they're going to have a standard error that we need to find using our formula, square root of PQ over N. And so that comes out to 0.75 times 0.25 all over 90. And then again, like I said, make sure you go through and do these problems with me. So the square root of 0.75 times 0.25 divided by 90, I got something that didn't make sense because I think I forgot to put in my decimals. 0.75 times 0.25 divided by 90. I got 0.00456. So I'm just going to round that to 0.046 there. And with this information, I am now able to move to step 3 and go find my p-value.